hit record here. All the sessions that I do online are recorded, and you will get a copy of that file if you want to review it.
Okay.
Okay. Now, hopefully you've got a few problems that you can verbalize. Pre-calc has, in other words, if it was geometry, it'd be a little different. You would probably almost certainly have to take a picture of graphs and stuff, send it to me, I would bring it up on my screen, and we would analyze it. Do you have any pre-calc problems that you can verbalize? We can get.
Yeah.
Okay, let's try that.
This one says find all the solutions for the triangle. Capital A is 36 degrees. Lowercase a is 8. Lowercase b is 5. And now we have to solve for the rest.
Okay. What law are we going to use here? You know?
Sine a over lowercase a equals sine b
Yeah,
over.
you basically have two laws in trig. One is the law of sines, and the other is the law of cosines. And those two laws will allow you to solve any triangle as long as you have three pieces of information. Okay? And we do. We have an angle, we have its opposite side, and we have an adjacent side.
All right.
Okay? So the first thing is, yeah, we're going to use the law of sines. And the law of sines says the sine of an angle versus its opposite side is a constant in any triangle. So I can say that the sine of 36 degrees divided by 8 equals what?
Sine b over 5.
So if I solve this, multiply both sides by 5, that is a number. Do you have your calculator in front of you? What kind of calculator do you have?
Casio CG10.
Okay, I'm not familiar with that, but I assume you know how to do that process?
Yeah.
Okay, so what do you get for sine B?
.367. That doesn't sound right.
Could be. Let's see, the sine of 30 degrees is a half. So the sine of 36, a little bit more than a half, times 5 over 8. Actually, it sounds right to me.
Okay.
However, notice what that is. That is the sine of B. That is not angle B.
Oh, it's all right. So you have to do.
So what's B equal to?
$21.5.
Now, have you come across the ambiguous case of the law of sines yet?
It doesn't sound familiar.
Do you want to tell them kind of that you've been out and all that?
Yeah, I gathered you had some problems of concussion or something, and you for a while. I tell you what, let's do this problem without the ambiguous case of the law of sines, and then we'll go back and we'll do it with.
Okay.
And it's important. I would imagine they've probably talked to you about it. Otherwise, they wouldn't be able to do this problem. Okay, so I know that angle is 21.5 degrees, right?
Yeah.
Okay, now, can I figure out angle C?
Yes. By subtracting angle A and angle B by 180.
Okay, what do you get?
122.5.
And now one more step of the law of sines will allow me to solve for angle C. In other words, and remember it's sine of A over A equals sine of B over B equals sine of C over C. So I can use this same relationship right there that I had, which was sine of A over A. So let's do that. I got the sine of 36 over 8 has to equal the sine of 122.5 over C.
All right.
And you can see that that's going to allow you to solve for C. Okay. Now,
All right.
I want to do this, well, the ambiguous case for the law of sines is the only confusing part of this part of trig. The only. If there was no ambiguous case, then the law of sines and the law of cosines wouldn't even take a day. It would be that easy. Okay? Every problem would be done similar to the way we did this. We would use the law of sines wherever we could. If you have a situation like this, where you say have that side and you have that side and you have that angle, well, now you can't use the law of sines. Over here,
Right.
you would have to use the law of cosines. You still have three pieces of information, but I do not have the sine of an angle and its opposite side. And you have to have that in order to use the law of sines.
All right.
Okay? And that really only leaves two situations where you have to start it out using the law of cosines. Have you had the law of cosines?
I think I missed that.
Okay. Given that, I am not going to cover the ambiguous case of the law of sines, but let's go in and start talking about the law of cosines. Okay? Because those are the two things you're going to have to know the most, or those two. That's what they're going to teach you the first, or those two. And then hopefully they'll go back and teach you the little more complicated version of the law of sines that involves the ambiguous case of the law of sines. I don't want to throw that right at you. Okay? So, you understand how we did this problem? Totally?
Yeah.
Okay. Even though I didn't take it to the end and come up with an answer, you can solve for C. It's algebraic. In other words, you have a number there, a number there, and a number there. So C is relatively simple to solve for.
Yeah.
All right. Now let's talk about the law of cosines. And the law of cosines usually means that at some point you have to use the law of sines also. So let's take that case that I gave you. In other words, I cannot start this problem out with the law of sines. I do not have an angle and an opposite side. And that's what you have to have in order to use the law of sines. Okay?
All right.
Law of cosines, there's actually three of them. It goes like this. A squared equals B squared plus C squared. A little bit like the Pythagorean theorem, only that's one of them. Second one is this one. Notice the pattern. Whoops, hold on. At least if I write it correctly, notice the pattern. What's the third one going to be?
C squared equals A squared plus B squared minus 2AB cosine C.
Those are the three laws of cosines. You can use whichever one is appropriate. Which one would I use in this case?
First one, a squared equals b squared plus.
So let me erase all this so I have some room. There is another situation where you could use any of the three equally. Okay, so let's fill it in. We get a squared equals 8 squared plus 7 squared minus 2, 8 times 7 times the cosine of 30 degrees. Notice that everything on the right side is a number.
Mm-hmm.
So a is going to be the square root of that. Okay. If I do a rough estimate of that, let's see, we got 64 and 49 is 113 minus 56 times 2, which is 112. Cosine of 30 degrees is square root of 3 over 2. I must have made a mistake here. 64 plus 49, that's 113. 8 times 7 is 56, times 2 is 112. Cosine is a positive number. So what is the... I made this one up off my head. And
I got 14.5.
Well, you're going to end up taking the square root of a negative number unless I made a mistake here. In other words, oh, no, you're right. I'm sorry. What'd you get for A? Good.
14.5.
Okay. So now that when I first looked at this, for some reason I was thinking this number was the square root of a negative number. And had that been the case, then this would have been an impossible triangle. In other words, when you use the law of sines or cosines and you get an impossible answer, it tells you can't have a triangle that's 30 degrees and then a side is 7 and a side of 8, which didn't make sense to me because it sure looks like you could have it. And indeed you could. I just was making a mistake in my mental math here. Okay, so now we have this triangle and we have 4 pieces of information. But more importantly, we have an angle and its opposite side. So we can finish solving the triangle using the law of sines. We don't have to finish it using the law of cosines. And every situation where you have to begin using the law of cosines, you always end by using the law of sines. Okay? So you use the law of sines in every triangle, but you only use the law of cosines in a few. And only if you can't start it out using the law of sines. So for the moment, let's go ahead and, now this is my problem, not yours, so I don't know that we have to come up with a precise answer, but you can see where I'm going with this. The next step is going to be the sine of 30 degrees over 14.5 equals, well, let's see if we can figure out what angle B is. That's the only unknown. We're going to do it exactly the way we did it before. Let's say we come up with a 75-degree angle. Now to figure angle C, I can just add those two, subtract from 180, and I get 75 degrees there also. Okay? Now, so we've solved the triangle. In other words, solving a triangle means coming up with all 3 sides and all 3 angles. It's just a question of which method you start with. Now, let me say one thing here. There are only 2 cases where you have to start with the law of cosines. And that is when you have what we just had, which was a side angle side triangle. You know what I mean by that?
Yeah.
Okay. The other case is side, side, side. That's it. Any other triangle that they give you and they ask you to solve it, you'll be able to start out using the law of sines. Now, why would we use the law of cosines with side, side, side? Let's say I've got 6, 7, 8. Well, I do not have an angle. I do not know what any of those angles are. So how would I use the law of cosines to solve? In other words, the first thing I got to do is solve for one of the angles. Once I solve for one of the angles, I'll be able to finish the triangle by using the law of sines.
All right.
So what equation should I use to solve for one of those angles?
Um,
I'll give you a hint. You could use any of the three.
I guess a squared equals b squared plus c squared minus 2bc cosine
A
a.
squared is 7 squared. That goes on the left. Equals b squared plus c squared minus 2 times 8 times 6 times cosine of a. Now, in this situation, notice that the only unknown is on the right side, but I can still solve for it.
Right.
So I've got 49 equals, see, 64 and 36 is 100. Unfortunately, this is a, it's going to be a right triangle, but that's okay. It still will illustrate my point. I accidentally made it a right triangle. But you'll still see what's going on. So let's see, 48 times 2 is 96 cosine of A. You with me?
Yep.
Subtract the 100, we got minus 51. Divide by minus 96. We've got that as cosine of A. You with me?
Mm-hmm.
Tell me what A is. Look up the inverse cosine of that number.
Uh, 57.9.
Okay. And now you see that we have, once you get 4 pieces of information, then you can always solve the triangle using strictly the law of sines. Because if you have 4 pieces of information, you have to have an angle and an opposite side. And that's what you need. And so I can finish out, I can solve for angle C using the law of sines, and I can solve for angle B merely by subtracting these 2 other angles from 180. And that's the common pattern when you have to use law of cosines. Use law of cosines to find out your 4th piece of information. Use law of sines to find out your 5th piece of information. And you just use the fact that a triangle has 180 degrees in it to find out the 6th angle or the 3rd angle.
All right.
And these are the only 2 situations where you have to start it out with law of cosines. And another thing is whenever you start out with the law of sines, you never switch to the law of cosines. In other words, if you start with the law of sines, you finish all the way through. The only time you use the law of cosines is the beginning step of those 2 kind of triangles. That's it. And only the first step.
All right.
All right, now we got about 7 or 8 minutes. I can do 2 things. I can cover the ambiguous case of the law of sines, or we can do something else that you would like to cover.
The ambiguous case doesn't sound familiar, so I guess I'll go over that.
Okay, I'm sure you're going to end up getting it. I'm just going to make an angle of sine of 30. And I'm going to call this side 6. And I'm going to call this side. Now let's make, hold on. I got to make sure that it fits the ambiguous. In other words, the word means exactly what it says, which is it's not always the case. Okay? Notice what we have. We have angle, side, side. Or side, side, angle.
All right.
When you have this situation, you have two possible solutions. Even though I have exactly 3 pieces of information, it's one reason that side-side angle does not prove congruency when you took geometry. It's because here's a case where side-side angle is going to be 2 different possible triangles. So let's try to solve this. Okay? So let me label it. I'm just going to go through it real quick. We got the sine of 30 degrees divided by 6 has to equal the sine of c divided by 10. So I've got 5/3 times 1/2, which is the sine of 30 degrees, equals the sine of c. So c is equal to the inverse sine of 5/6. You tell me what that is?
Uh, 56.4.
From your trig, what other angle could it be? Remember, sine is positive in first and second quadrant, so it does not have to be a first quadrant angle. How much trig have you had? Have you taken a trig semester yet?
You had
Barely.
you had algebra. You had algebra 1 in 8th grade, geometry as a freshman, algebra 2 as a sophomore.
Okay.
We came from Texas.
They give you a little bit of trig in algebra 2 and they give you a little bit of trig in geometry. I'm not sure you've had, maybe the reason you haven't had the ambiguous case is because you haven't had enough trig yet. Let me go ahead and finish out this problem. I think you'll see where I'm going here. Angle C can be 56.4 degrees, or it can be its supplementary angle, 123.6 degrees. Okay? Now, the question is can it be either of those? Well, I can certainly make it 56.4. And that would make this angle up here about, what, 93.6? Now, that's one of the triangles. Okay? But what's another triangle? Another triangle that has those same exact dimensions of 10, 6, and 30 degrees. Notice that it's got exactly the same 3 pieces of information on the angle side. Only in this case, that is 123.6 degrees, which now makes this angle, let's see, what's that, 153, so this would be 26.4. And there's your second solution. In other words, even though they told you angle A was 30, side C was 10, and side A was 6, there were 2 possible triangles that fit those 2 considerations. That's why it's called the ambiguous case of the law of sines.
All right.
Now, I've had a number of trig books, and man, I had one book that wanted me to memorize a whole page of information to know when this might be, because you don't always have an ambiguous case of the law of sines, only in certain instances. In other words, if angle A is greater than 90 degrees, you never have it. If the relationship between side A and side B is a certain percentage of the sine of 30 degrees, you don't have it. So there's all kinds of rules you can memorize as to when you might have the ambiguous case. The easiest way to do it is right here. When you figure out what that angle C is, always figure out its supplementary angle, and then see if there's room for that supplementary angle. In other words, the only angle I know for sure in this triangle is 30 degrees. So could I have an angle C of 123.6? Yeah. I don't exceed 180. If this number would have exceeded 180, then I just cross it off. I don't have the ambiguous case, and I would only have one solution. So it's always a question of checking that supplementary angle to see whether or not there's room for that. In other words, let's say this came out to be 151. Well, 151 and 30, the only other known angle in the triangle, is greater than 180, so that would not be a solution. So that would not be a solution. And the only solution you would have would be your one solution.
All right, it makes sense.
So it all kind of depends on what that second angle comes out to be and whether it fits in the triangle. And that's why it's called ambiguous. In other words, there aren't always two solutions. There just is occasionally two solutions. And you have to be able to check which it is. The fact that you're getting the law of sines and probably the law of cosines now probably means you also have gotten the ambiguous case. It's just you've been out and weren't there for it. But usually they teach it together. It's rare that they teach the law of sines without teaching the ambiguous case of the law of sines. And like I said, it's really the only hard part about it, about the law of sines.
All right.
Okay. So anyway, Donovan, let's go ahead and end the first session there. As I said, I'm making a recording of this. I'll have it to you. I'll send you a link. Let me make sure I have an email address for somebody. G. Burdette. Yep, I've got hers. I'll go ahead, or your dad's or yours, whatever, and I will send a link to this recording by tonight, and you'll be able to review it at your leisure if you like. And that's the way my online sessions work.
All right, cool.
Okay, now if you want, you can also sign up for sessions on my website directly without talking to me. In fact, whoever signed this one up did it that way. The next time you have a session is all I will do is text the meeting ID number to the phone number.
All right.
In other words, I won't call you. You don't have a need to be, I don't need to work you through the download anymore. It should be on the desktop. If you look on your desktop, you'll see an icon that looks a little bit like this orange flower that I'm pointing to.
Yeah, I got it.
That's the GoToMeeting. Just if you double click on that, it will ask you for a 9-digit meeting ID number. I will have texted that to you. Boom, we're in a meeting.
Cool.
Okay?
All right.
Donovan, nice meeting you, and hopefully we'll work together here.
Yeah, well, thank you very much.
All right, and to close out of this one, you just need to click on the X in the upper right hand.
All right.
Bye-bye.
Bye.